Okay, we're back today. Today we're going to look at a pretty easy concept, but they make it pretty difficult here. This is specific probably to the ACT, and it's just the least common denominator. And we're going to go through a couple examples today because they like to ask this, and they ask it a lot very late in tests, and kids take it for granted that they know what it is, but they don't. And so here we go. We've got some ugly looking fractions, and from that we're supposed to determine what the least common denominator is. So take a look at it, see if you can make sense of it. We could pause the video and then we'll come back and we'll make sense of it together. Alright, so here we go. Some big numbers, and I think the one thing you don't want to do here, keep in mind these tests are designed to be done without a calculator. Certainly you want to use a calculator, but I think the point they're trying to get across is that you don't need to do crazy computations to get this stuff right. I think what kids are going to try to do here sometimes is they're just going to multiply all this stuff out, and they're going to get some really, really big numbers. Yeah, I would not do that. Number one, that's not necessary. Number two, remember to always look at the answers. Let the answer choices guide your decision as to what to do, especially on hard ones. So you can see they don't do that, so then we're not going to do that. Now, least common denominator, we're dealing with a bunch of numbers with exponents in them. There's a very easy rule, and if you remember this, you're going to get all these right. The least common denominator is just the highest degree of the exponent. And what I mean by that, right, if I had 2 to the 7th, the 7, that's the degree. So you're just going to look at each number here, and you're going to determine the highest degree, and that will give you the common denominator. So first we'll look at the 17, right? That's just 17, so that's like a 1 implied there. So that's 17 to the first, that's 17 to the second, and that's 17 to the first. So we have a 1, a 2, a 1. Pretty confident we know 2 is the highest, so I know 17 squared has to be in there, right? And then I look at the 23. There's a 1, there's a 1, there's a 3. What's the highest number? 1, 1, and 3? 3. So it's 23 to the third. And then I look at the 61. Well, there's a 61 here. There's no other 61s here. So I guess it's just got to be 61 squared. So now I look for that answer. 17 squared, 23 cubed, 61 squared. So it should be this one. And sometimes you see it like this. Sometimes you see it like this. I've seen this question a few times where they'll give you, a pretty large exponent, something like that down there. And they'll ask you to do that. And a lot of times if you try to put that in your calculator, right, you're going to get some overflow. It's just too big of a number. And you just think to yourself, well, when we add fractions, what's the first thing, that we have to do? What do we learn in elementary school? You have to get a common denominator. And in this case, you look at it, and we have the same bases, which is always a good thing. And we just look at the exponents, and it looks like, obviously, 105 is bigger than 104. So I know the common denominator here is 12 to the 105. So I'm just going to keep that one right there. And then I have to ask myself, well, what do I have to multiply 12 to the 104th power to get to 12 to the 105 power? And a lot of kids should know this, right? We keep the base, and if I do that, right, that's going to give me 12 to the 105, because when I multiply with exponents, right, the base will always remain the same, and I just add the exponents, right? Oh, that's a 1 there. I always add the exponents. Go back to what you know. When you do something like this, what's that? The x stays with us always, and we simply just add the exponents. So in this case, there's your common denominator, and really this would just be, well, 12 times 1 is 12, plus 1 is 13, so it would really just be 13 over that 12 to the 105 power.